In this video, we're going to dive into how a battery works internally more than we did in class. And we'll talk about energy. So first, in class we said this: the chemicals inside the battery place electrons on the positive terminal of the battery. So the chemicals inside of here, they do their work and they place electrons on that positive terminal. Same thing here. More electrons here because the battery is more powerful. I want to say more here. I'll read this, but we didn't say much about how a battery does this, and I want to go into that in this video. But first I want to go back and also touch base with how a battery works on a circuit. Okay, so we have the battery and a wire, and we have electrons moving. A wire attaches the positive negative terminals, positive to negative. The wire and the battery form a circuit at that point. Same here, positive wire to negative circuit. Electrons flow from the positive to the negative terminal, that, and like that. The battery functions as an electron pump. That's a term often used to describe a battery in a circuit. It's just pumping these electrons on here, isn't it? And those electrons become electricity or current, and we can do things with it. And the obvious thing is, the last thing is, more voltage, more electrons. 9 volt, more electrons flow. Weaker battery, fewer electrons flow, less current, less electricity. Now back to how it works internally. Atoms have protons and neutrons in the nucleus and electrons on the outside. And to hold this whole thing together, it takes energy. It takes chemical energy. So now, an electron leaves down here, okay? When an electron leaves an atom to become electricity, chemical energy decreases. The total chemical energy of that atom is now less than it was before. Where did that energy go? It doesn't get destroyed, does it? It goes into electrical energy. So chemical energy decreases when this atom leaves, and electrical energy increases. Here's your code, chem energy. Chem energy is your video code. I'll read this. The kinetic energy of the moving electrons is electrical energy. So when these things are running in a row to provide electricity, they're moving, aren't they? Remember the thing called average molecular kinetic energy? Right. That is electrical energy because they're moving. So just an overview. Batteries convert chemical energy to electrical energy. Here's a brand new battery. Just came off the production line, and the chemicals have not done their work yet. Where's the energy now? It's all it's all chemical energy. There's no electrical energy yet because the electrons have not moved. Then quickly, after it becomes produced, the chemicals start operating, don't they? They take the electrons off, deposit them here. The chemical energy has now gone down. There's still some left because the battery is still functioning. There's still some, but now there's electrical energy. The chemical energy has been converted to electrical energy, and that's what batteries do.